Thank you. So nobody cares where I work, so let's skip it. So we call ourselves engineers, right? And yet we do nothing like auto engineers. This is the way auto engineers assemble a complex thing, like a car. They take a bunch of parts, each part has an exact specification, each part has been built and tested separately, and then the car is just assembled. Yet we have a ginormous repository where we hack inside, and it's almost like changing like a distributor cap, rebuilding it while the car is running, right? We do nothing like real engineers. So for me, a node package is equivalent of a part. You have exact specification, name, and version. You have parts that it relies on, right? So it's built out of these parts. This is red because I hate the fuzzy characters. Wildcards in your dependencies will always cause you problems. I like this, exact version. So first advice, use exact version in your package.json. So there's an option for that, or there's a tool like for that. But we'll always clean your package, so you will never have fuzzy versions, and your clients will never have a problem when they say, oh, it doesn't work, and you're like, no, it works for me. Oh, you install a different patch. Too bad. So second advice, only worry about your immediate dependencies. So your application is the top module. It depends on these two. You don't care about what it depends on, how it's built, or what it does. You only care about semantic versions. That's it. Which brings me to semantic versioning. So major, minor, patch. Okay, forget these names. They mean nothing. You might as well call it unicorn, stars, angels, whatever you want. What really matters is this. If you start with one version and you go to the next version, these three parts have a meaning. If a major version changes, that means someone broke something. If a minor version changed, that means someone added a new feature, but he has not broken existing features. And finally, patch, nothing has changed except those bug fix. No new versions, but nothing was broken. Which brings to the biggest problem with using lots of modules as opposed to a single repository. Modules are constantly getting out to date, right? So in this case, I depend on module A, 100, and there's already 101 and 200. And the question arises, can I upgrade? Right? Maybe I want bug fixes, maybe I want performance improvements, maybe I want new features. And the answer to this very simple question is nobody knows. A patch can easily break you. A major upgrade might not break you. It's a total guess. And the problem is that the package maintainer or author manually upgrades the major, minor, and a patch version numbers. It's the same as you said, I'm not going to rely on my compiler, or linter, or tests. I'm going to rely instead on user comments, or programmer comments in my code. It's totally human dependent. So let's change that. So we wrote a package called next update, and here's it in action. So let's say I have a project. It depends on a bunch of things that are already out of date. I want to check if I can upgrade to these things. So here's how easy it is to do. You type next update. I'm also giving an option not to print anything. So it runs a unit test to make sure your project has unit test, finds everything that's out of date, installs it one by one, runs the unit tests again, reverts back. At the end, it even gives you a command what can be installed. So you can just copy paste. There are lots of options. You can even say just keep everything that's working. Okay, so that's nice. But the question is, if I upgrade 10 dependencies, what am I getting really, right? Is it minor patches? Is it some new feature? Is it something major? So we wrote another tool called changelog. That we actually integrate. You can run it by yourself or integrate it into next update. So when you run next update, in this case, I will run it for a single dependency. It will do the same thing. It will test it. And it passes. But then it actually goes to NPM, figures out the Git repo, goes to the GitHub repo, and figures out all the commit messages between these two versions. So you know what you can upgrade and what you will get. Every time you run next update and it tries something, and it tests a particular upgrade from version XYZ to XY prime Z, it will actually send anonymous statistics back to the server we're running, and all it will say is that, let's say, I tried to upgrade Nodejs from 101 to 121, and it failed or passed. And then we just keep aggregate number, and every time you run next update, you actually see this, and this gives you probability that your upgrade will be successful. Because you might not have a lot of unit tests, right, for this particular dependency, so we actually do this for you. Again, doesn't guarantee everything, but on average, it's a good statistics. Also, we use the statistics to look at every change, and then we can compute semantic version adherence. As you probably know by now, Nodejs is really, really good about following semantics of semantic versioning. And underscore is not good, because its author is like, anyway, he's a weird guy. Ramda, my second favorite library, also does not, but because it's only below 1.0, which you can break things. Okay, so now you think, well, I can upgrade one project automatically, but now I have 100. Well, we have a tool for you called Next Updater. It can grab all your NPM packages or all your GitHub projects, run next update, update whatever works, commit it, tag it, publish, right? So software is taking over your job. And you can be very conservative. If you're scared, you can just say just upgrade minor or patches, whatever you feel comfortable. Now let's look at the opposite problem. So you have a module, a bunch of people depend on the module. How do you release something and not break everyone? As opposed to underscore or backbone or CoffeeScript. Notice the pattern? So this guy, Stephen Bunman, he wrote a tool called Semantic Release. And it's a Travis job that runs your own old unit tests against new code. And if you have not broken your old unit tests, then it thinks it's either a minor or a patch. But if you broke your old unit tests, then you have to increment major version, and then it increments the major version and publishes for you. So your version can grow very quickly, but you follow semantic principles. Well, we kind of decided, why just run your own unit test if you can run unit tests from all the projects that depend on your module? So for example, if I'm Nodejs and our projects are using that, I can just say don't break, and it will go download each project or top 10 or most popular 20, run with old version of Nodejs, put the new version in, and test again. So this way, I'll know if I'm going to break everyone who depends on me. So this is kind of our principle. And if I'm breaking something for projects that worked before, but maybe I should upgrade the major version. It's not difficult. So in conclusion, we have a bunch of tools that are all open source. Just install them, use them. These two tools will tell you what has changed if you're out of date. What is the probability that this upgrade will be successful or useful or simple? And then if you're releasing something that other people or other teams depend on, you can run these tools, and they'll tell you right before you release, hey, don't release, or or change the version number because you're going to break everyone. And finally, if you depend on other modules, you can easily test your software, keep it up to date. Like we never manually upgrade stuff anymore. It's always like, oh, just automated stuff. If you like things, I have a bunch of blog posts about software and updates like this on my blog. And finally, like everyone else, we're recruiting. We're in beautiful Harvard Square in Cambridge. And we're in beautiful Freedom Tower right here in downtown New York City. Any questions? Thank you. Yes?
Does it work with private NPM registries?
Probably, but I haven't tested that much. I know for sure changelog works, and you can actually authenticate with GitHub, even using two-factor. But if something is not working, just let me know and we'll fix it. Or you can fix it yourself. Make everything public.
So you guys wrote this all in-house?
Well, so some of these tools I wrote before the current job, but our company has a bunch of modules that we released open source, and we welcome open source work even during hours, because these are tools, we're like Facebook of NPM. We believe in developing tools that we share with everyone and that improve our workflow and everyone else's. But we're better than Facebook.
What happens for projects that do have private dependencies, like maybe GitHub
So we actually skip the GitHub hashes, right? We say we don't know what to do. I'm still trying to figure out what to do about GitHub hashes. I think at this point we literally can stop depending on particular tags and versions and just go by commit hashes and like find the commit that works and then stops. Like almost like bisect, but for dependencies. Well,
So does changelog still read your package.json and it will still compare? I'm just what changelog does without next update.
Changelog, you can just say what changed in Lodash between 3.90 and 3.95, and it will figure out the GitHub and fetch you the commit messages. It's just a utility to simplify your life. Cool. Oh.
How is this going to handle NPM's new package managing tool to get rid of dependency hell? So if you have a project that's dependent on another project and then you have other projects that are also dependent on that, it's not just going to load it 10 times. It's going to have one copy of it.
Well, how does NPM handle it right now, right? It doesn't. So you can have. It's, yes, so I think these tools do not solve the problem, but they make upgrading everyone up to the level that works, that's common, maybe the latest, or the latest major, very, very simple. Cool. Thank you, guys.